Okay, so hello everyone. See, this is a question related to perceptron, and these are the possible questions in basically in semesters. Okay, in university questions. So here you see here, given a perceptron model with two inputs. So here you have two inputs for the perceptron, and corresponding weights. Two inputs means you have to provide two weights, and learning rate also given, threshold value also given. So here the question is, what will be the updated weights after training on each inputs of the AND gate dataset? So here before we try, we have to do two things. One, we have to provide the dataset for AND gate. Then here two inputs, two weights. On the basis of that, we have to design the perceptron model first. After that, we will try to update the values using our perceptron algorithm. So let's see here. So you can see here that, so basically I can write here the AND gate data set. You can find here the AND gate data set is like that. So the data set. So let me write the data set first. So how it is looks like. So if there are two inputs, you know that in AND gate there are basically two inputs, two input AND gate, and let y is the corresponding output. Okay, so you know that for two combination of input, so if y1 and x1 and x2 0 0, then it's y. What is the value of y? The value of y is equal to 0. So you all know that AND gate provides output 1 when both inputs are 1. Otherwise, it is going to provide 0. So when both inputs are 1, the AND gate is going to provide you output is your 1. Okay, so this is the data set, and also we have to create our perceptron model. So how it is looks like. So here this is the perceptron. It receives input. Okay, so here two inputs are there. Two inputs. One is x1. Okay, in the question it is given. Okay, x1 and x2 are the two inputs. Okay, and here the weights w1 is given initially 0.9, and w2 also given initially 0.9. Okay, so you all know that perceptron, after receiving the data, so first it finds the weighted sum. So if z is my weighted sum, so I can write here my z is equal to w1. I can write here, like I'm writing w1 x1 plus w2 x2. So this is the way to find z value. So once we receive the data, we have to find the weighted sum, that is z value, and this data is now going to activation function. Here our activation function is that. Okay, so we have to pass this to the activation function. Okay, so now it is going to produce the output. It is going to produce output y. So here its name is y cap. So here output y cap, I can write here the function. It's a function of actually z. So how it is going to provide me output? The output is basically, how to find the output is going to be. So all of you know that what is step function. If I write here y cap, how to find the y cap? Y cap is equal to this is the threshold. How it decides the output? How it decides the output? It is going to be 1 if my z value greater than equal to threshold. So here basically I can write, here you know what is threshold. Z should be, okay, threshold value, and it is going to be 0 if z value less than threshold. Okay. So here in this case you try to check that what is the threshold. Threshold is 0.5. Okay. So I can replace it here. Otherwise I can write. So here threshold value 0.5. I am writing in the bracket. So if z value greater than 0.5, my y output is equal to 1. If it is less than 0.5, my output is going to be 0. So what actually Perceptron algorithm telling? First you have the inputs, you find the weighted sum here. Once you find the weighted sum, you provide this value to the threshold function. Threshold function will predict the output according to this logic. Okay. So once we find the y value, this is the predicted output. After that, we can get the errors. Okay. So before we go to find the errors, how to find the errors? Error is equal to your y minus y cap. What is y? Y is the real output. For example, in this case, this is the real output. And what is okay? Let's start and parallelly we can do that. So let's go to the step 1. So in step 1, two inputs are there. One is x1 equals 0, x2 equals 0. Let's we provide it here and see what the output it is generating. Okay. So step number 1. So you write step 1. Okay. So in the step 1, I can write in the step number 1, my x1 is 0 and x2 is 0. And also initially what are the weight also we have to consider, and now here y is given 0, and here initially what is the weights, it is given in the exam question 0.9, and what is my w2 also 0.9. So using this data, now we have to predict, we have to calculate the value of z. So now what is z value? I can write z value is equal to w1 x1 plus w2 x2. Okay, which is equal to, what is my w1? My w1 is equal to 0.9 into x1 is equal to, this is my x1, here I am written 0, x2 also 0, 0 plus w2 0.9, x2 also 0. So total I am getting z value 0. So my z value here 0. If z value 0, now what, here this 0 is coming now. So for x equal to 0 and x2 equal to 0, my z value is 0 coming. Now this z is going to pass to activation function. Here you pass, here xz, z value is 0, which is less than threshold 0.5. So my output y cap is going to be 0. Okay. So for this combination, my output equal to 0. So my y cap is equal to 0. I hope you understand. So now here the weight updation process is going to start. So before that, we have to check what is the error. So error here, what is error? My error E is equal to my actual output minus predicted output. What is my actual output? My actual output is 0. And what is my predicted output? Predicted output is, here also I got 0. So the logic telling that when both are same, then there is no need to update the weights. So here both are same, error is 0. Once error is 0, according to the algorithm of Perceptron, no need to update the weights. We keep it there. So after this round, our W1 is equal to 0.9 and W2 also 0.9. There is no change. So finally I can say, so after step 1, my, so what is my W1? I got my W1 equal to 0.9 and also W2 0.9. So here no update happens. It remains same. No update happens. So in this case, all the things remains the same. Now I have to consider second step 2. For step 2, I have to take this data, this line I have to take. So here for step 2, okay, so for step, let's try for step 2. In the step 2, so what is my x1? My x1 equal to 1. My x2 is equal to 0. X1 equal to 0 and x2 equal to 1. Okay, my output, real output equal to 0. So now what, and also what is the weights? So we have to take weights from the previous step. So weight now, W1 is here, my W1 0.9 and my W2 is 0.9. No change happened in the previous step. Now I have to predict the Z value. So here my inputs are like x1 0 and x2 1. I have to provide here. Now this I have to do the calculation, W and W2 same. Do the calculation, you find the Z value. So my Z value here, Z is equal to what is W1 0.9 into what is my x1 0 plus what is W2 0.9, what is x2 1. After calculation I got that this is 0.9 into 0 plus 0.9 into 1, that is 0.9. So finally I got 0.9. So here in step 2 my Z value I got 0.9. Now this 0.9 is going to pass to the activation function here. Okay, so here activation function it helps us to predict the y value. Now question is, what is the y value? Y cap is equal to, here you see 0.9. What is the threshold value? Now here Z is equal to your 0.9, and what is the threshold value? 0.5. Since 0.9 is greater than 0.5, my predicted value is going to be my y cap. My y cap is, now I can say my y cap is 1. So my predicted value is 1. So let's start to find the error. Okay, so now let's start to find the error. So here error is my, what is my error? Error is equal to y minus y cap. So my, what is my y? 0. And what I got? Y cap. So you can include y cap here also. Here previous case 0, here I got 1. So you see here the difference is coming. So if I 0 minus 1, so here my error is minus 1. So you see here minus 1 coming. So if error is coming, then we have to update the words. So how to update the words? So now there is a formula to weight update. You have to write down the weight update formula is W1. Here two words, W1 will be W1 plus learning rate eta into error into input x1. And what is the weight update for W2? W2 equal W2 plus eta learning rate error into x2. So this is the formula to update the weights. Okay, so we are going to update the weights. So use here, now my W1 is equal to W1. What is W1? Previous steps you put here W1 plus eta into error into x1. So if you do the calculation, you find W1 is equal to W1 0.9 previous 9 plus what is eta? Your eta is equal learning rate 0.5. Okay, into what is error? Minus 1. Here error is minus 1 into your x1. What is x1 here? 0. Okay, so here 0 means multiplying 0 with these things is going to be 0. So answer is going to be 0.9. 0.9. So you find 0.9, W1 0.9. So here nothing changed for W1 case. Now let's to find W2. Okay, so now your W2 is equal to W2 plus eta into error into x2. Which is, what is W2 previous case? 0.9 plus 0.5 the learning rate, and minus 1 is my error into 0 into input x2 equal to 1. If you do the calculation, you will find that 0.9, so here 0.5 minus 1 multiply, it is going to be minus 1 minus 0.5. So if you minus that, you will get 0.4. So in step 2, we got that W1 is 0.9 and W2 equal to 0.4. Some change has been here, some change has happened. So the same thing let me apply for step number 3. So space is not there, I am going to update here. Okay, so you can see to change the words. Okay, so you see here, follow the same thing. Now step number 3. So in step number 3, what is going to happen? So you see in step number 3, okay, so step number 3 we have to apply here in this example. So here what is x1 equal to minus 1, x2 is equal to minus 0. Okay, and what is the weight? So we have to take weights from the previous step. So here W1 is equal to 0.9 and my W2 is equal to 0.4. Now with this case now starts. Okay, so now your inputs is x1 is 0 and your x1 is here 1, x1 is 1 and my x2 here now 0. Okay, so now you apply the same procedure you follow and you multiply, weights are updated, second this is also updated. Now you calculate, so multiply z value. Here you see 0.9 into 1, that is you calculate the z value. If we follow the same procedure, no need to calculate again and again, you directly multiply 0.9 into 1, that is 0.9 plus w2 into x2, 0.4 into 0, that is 0. So finally you get 0.9. So this 0.9 is going to pass to the activation function, and since this is greater than the threshold 0.5, so my activation function is going to predict to y cap, that is going to be what? That is going greater than something, it is going to predict is 1. Okay, so it's predict 1. In third case also it is predicted as 1. But what is the real output? 0. What is the predicted output? 1. So here error is persist. So what is my error? Error equal to 0 y minus y cap, that is 0 minus 1, which is equal to minus 1. So error is coming. Error is coming means you have to update the weights. So how to update the weights? So now my new W1. So W1 is equal to W1 means which W1 I am going to use? 0.9 old W1, 0.9 plus, okay, let me write the formula better, that W1 plus eta into error into x1. Okay, so let's proceed. So what is W1? W1 0.9, okay, plus what is eta? 0.5, okay, into what is error? minus 1. Okay, so here we see 0.5 and error is minus 1 into 0. So I got the weights 0.5. So now let's go for step 4. Okay, so already here. So for step 4, you have to take what is the inputs. You have to take this as the input. Okay, so you see these are the for this you have to take. This is the training example 4. Here x1 equal to 1, x2 is equal to also 1. So your output is true output is 1, and now we are going to predict the output for new output according to the perceptron model. So now how can we do this? So let's start. So before that you have to write down what are the weights of the previous step. So here I can write down W1 from previous step is what I got. I got here 0.4. And what is the weight of W2? This is 0.4. 0.4. So both already I got 0.4 from the previous step. So now I have to update. Before that, let's provide the input to this model. So for this as a training sample, here x1 is 1 and x2 is 1. And what are the weights? Weights already both updated, 0.4, 0.4. Okay. So now we are going to calculate z value. So how to calculate? Just multiply W1 into 1. So just write down here, just your z is equal to W1 0.4 into your weight 1 plus W2 0.4 into your input 1. So what is the value? 0.4 into 1, 0.4 plus 0.4, that is 0.8. So now you see 0.8 is now the value of z. Okay, the weighted sum value 0.8. Now this value will pass to the activation function. Activation function will do the prediction. Okay, so what is the value of y? Predicted value of y. So if the z value greater than 0.5, greater than the threshold 0.5, it is going to be 1. So you see here 0.8 is greater than 0.5. So obviously here it is going to produce output 1. So your y cap value is going to be 1. You see here now both you see both predicted output and both real output both are same. So since both are same, here no need to update the weights. It is going to be remain same. So after that you can write here error is 0, here error is 0, so I need to update the word. So error is equal to y minus y cap, which is equal to 1 minus 1 equal 0. Since error is 0, you can write down here no updation required, no weight updation required. So we are not going to update the no weight updation required. So we are not going to, so here no need to update. Okay, so you can write it. Okay. Over. So now this step is over. So you see, remember that in this training data set, how many samples are there? Training sample, one training sample, 2, 3, 4. 4 training samples are there. So in each training sample, this part is known as input X and this part is corresponding output. Okay. So in the training data set, the all training sample, for all the training sample, we have updated the weights. So this all set is known as one epoch. Okay. So what now we are going to do? For one epoch we have updated. So this is known as one epoch. Okay. So for one epoch we updated the weights. Now question is, this whatever weight we got after one epoch, can this weight is going to predict perfectly? So we have to check again. So for another round, another iteration, we have to check from the beginning again. Okay. Now you see, after one epoch, what is the weight? 0.4 W1, W2 also 0.4. Now we have to test that can this weight providing perfect result. For again, if I test, if they are producing perfect result, then we can say that these weights are okay. But for this question we have done, because it asking to update the weights for all the training sample. For all the training sample we have updated, we got the value 0.4, 0.4. Still we want to see really this weight can predicting perfect or not. So now you provide 0, 0, 0, 0 here and provide this. You see here, if you multiply the 0.4 into 0, 0 plus 0.4 into 0, 0, and this 0 is coming here. Okay, and this is less than 0, 0.5, your output is going to be 1, 0. So that means here also real output, predicted both are same. Now coming to second training sample. If I provide, this is the training sample, x1 is 0 and x2 equal to 1, and here weights are 0.4, 0.4. What will happen in this is 0 means this multiplication part is 0. Now you consider this part 0.4 into 1, that is 0.4, which is less than your threshold 0.5. So your prediction value is obviously 0. So here prediction value 0. You see here both prediction value and real output value both are same. Now again let's go for the third round, third sample. Here your x1 equal to 1, your x2 equal to 0. Since it is 0, this multiplication part is 0. You consider this pass 0.4 into 1, 0.4. Again this is also less than 0.5 threshold, and so this predicted output part is 0. Now going for 1, 1. 1, 1 already tested. If you both are 1, 1, so multiplication is going to be 0.4 plus 0.4 or 0.8, which is greater than 0.5. So your prediction is going to be 1. So that means I can say for these weights, this perceptron can do perfect prediction. Okay. So this is the thing, this way the perceptron is working. Using the same way, we can also update the weights for your OR gate. This is for AND gate. We can do the same thing for the OR gate. Okay. Thank you for watching. We will see in the next video for OR gate.